In this talk, we will look into, basically we will look into links in emails and how to detect the malicious ones. We're going to take a quite narrow perspective on a very well-known topic, which is domain and URL detection. But we're going to try to do this as cleanly as possible, because I think we all know how bad it is when there is a malicious link waiting in an email inbox to be opened. First, some words about me. I'm a data scientist at a German company called Net at Work. We provide email security solutions via no-spam proxy. And I'm part of the 32 guards team, which is essentially the data team, which is analyzing all the email metadata, doing the detection, and kind of managing all this data. I love to catch fish every day. And yeah, I'm passionate about email security. So happy to talk about this. To warm up a bit, a quick show of hands. Who would click on this link? Oh, yeah. There's some in the audience who would. I think many of us are very suspicious, maybe. But yeah, if you're a suspicious individual, you would maybe check up this domain in VirusTotal, and you would already be warned saying, oh, this is spam, don't click on it. If you would check the website behind it, you would land on the quite random looking news page, having nothing to do with the domain. I think that would be the point where most people would think like, okay, this doesn't seem right. Does anyone by chance know what kind of spam or scam is behind this? No? Okay. It's, so in the emails that are kind of containing these domains and links, there is another link, which is a kind of redirecting seemingly to Google. But yeah, if you dissolve the redirect, you're actually going to land on this kind of crypto ChatGPT trader kind of scam. Where, yeah, I think we all know the topic is quite prevalent right now. In Germany, there's, or maybe also somewhere else, there's the spam campaign going on using very well-known celebrities to kind of increase the legitimacy of these trader GPTs, where you can kind of earn a lot of money very fast. There have been some cases where people have lost a lot of money. So yeah, this is kind of the basis. How can we detect these cases thoroughly? A quick agenda, which is actually the technique overview, will be we will look into URLs and the metadata. We're going to detect the domains. And then we're going to extract regex patterns. And based on then, we're going to kind of extend the domain detection to these new patterns, to these new domains. Then we're going to group the regexes and filter them by n-grams. So the basis of all this is email metadata. And this means we do not have access to any content, written content of the emails. So it's a kind of data protection service that we offer. We don't store the text. We actually don't see it. We don't have access at all. So we have to do our detections based on these things. So we have the mail source IP, we have the mail from, the header from. We have some email security, so authentication checks that we verify, whether SPF, DKIM. We have the CSA, which is the Certificate Sender Alliance, which is a whitelist for newsletters, basically. We check whether they're on this whitelist. And then we have all the URLs. We also have all the URLs from the attachments that we get. And we have the file hashes of all the attachments that come in. And based on this, we have a very large continuous stream of data, millions of URLs that we need to detect immediately in best cases. No one wants to wait on kind of their business email coming through. So yeah, first of all, we're going to apply some well-known techniques to detect whether something is spam or ham. A short note, whenever I say spam, I actually do mean spam and phishing. Yeah. So when we have this kind of URL, There are some methods that do URL detection. The recent ones look into using each character of the URL, putting them into an embedding, putting this into transformer type models, so neural networks, and try to detect each URL. These models are quite complex, and we actually need to explain whenever we block an email. So we need to have some more simple, more explainable approaches that we use. So there is domain detection, which is one level higher. You only detect the domain, and then you can block all the URLs related. And in these detection methods, you, in most cases, have some form of data that is, so you have the domain and you want to detect it, and you have additional data that you actually put in through. I know that there are many techniques that kind of use the information from the website, for example, the domain is pointing to. But in our case, we do have the email metadata. And this is mainly frequencies, features that we put in. So in how many emails was this domain seen? Also time feature, how long is it since it was first seen? And the rest of the metadata in aggregated format that we showed in the beginning. So this could be things like how many inbound emails, how many trusted sender emails did contain this domain. And so far so good. They work quite well. But with new domains, you always have the problem that you need to collect some form of additional data before you do the detection. So in our case, we have aggregated data, and we need to wait at least a few minutes to kind of collect this additional data in order then to detect whether this is probably malicious or not. And in this short time frame, emails can come through, and this is bad. So we were trying to look how we can improve this kind of basic detection algorithm and expand kind of the impact of the detections to then, be quicker, basically. So this is the basic technique behind it. We use regex patterns in order to describe the lateral part of the URL. So we have we keep the characters with meaning from the URLs. So in the path part, it would be the slashes, query part, the question mark and equal sign, and so on. And then we describe kind of the string in between with the type of character, lowercase, uppercase, number, and special characters, and then the length of the string. For the fragment part, we also extract whenever it's an email pattern, because it's a quite popular technique to kind of pre-fill login forms that should be completed, like pre-fill it with the email address of the victim. So yeah, from this URL, you would then get the regex pattern that you see in the bottom. So what we target here is kind of the campaign level detection instead of domain level, because then we kind of have a complete overview of the spam campaign or new domains that are coming in belonging to the same campaign. To see an example, we have here the regex pattern in the top. There are some domains, not all of them, but some example domains that are related to this kind of spam campaign. And the dots are representing the domains. And we connect the dots by whether they share the same mail source IP, to give you kind of this overview and feeling of this network kind of character, and that they all relate to each other. I want to highlight the red circle on the left side, which is that in many campaigns, it's actually quite usual to kind of distribute the load of spam emails sent on many mail source IPs, because then to kind of evade detection. And with a regex pattern, we're going to see we can kind of still group them together. So yeah, if you check one example domain, we actually see This is like the same spam campaign that we saw in the beginning. They all have random news pages that all quite look the same. And yeah, if you click on the links, you will get to this GPT trader scam. So let's look at how impactful this is. So some results, I'm not sure, I hope it's visible. So we have the domains of the spam campaign on the right side, and then we have a timeline at the bottom. And you can see the red dots, which are showing the first time a domain was seen, and then in blue dots for how long the domain was reoccurring. And what we can see here is that domains tend to not be persistent for a long time. So this is very common. I think threat actors regenerate new URLs very fast, and they never live for a long time, because whenever they're on blacklist, of course, they will not get through anymore. So with the regex patterns, we can actually kind of reduce the analysis window of a new campaign, and by detecting what is in the red box, kind of, we then have a pattern that we can match against new incoming URLs, and like all the domains coming afterwards, and also coming maybe in like the time period going on, depending on how long the campaign is running for, we can then detect them right from the start. So whenever you have these detection algorithms, you always have also some errors that they don't detect every domain, or like there are these incomplete detections. And yeah, we figured that by matching this regex patterns from kind of already detected domains, we can then kind of extend or detect new domains right from the start. For us, it helped to catch 90% of the URLs missed by domain detection, which is quite a big amount compared to kind of only relying on this domain detection. So this is kind of the main technique. Now that we have these regex patterns, we were trying to look what we can do else with these patterns. So what we figured is that, of course, there are multiple patterns that kind of describe the same spam campaign. And you can see here, like the lateral part is always changing up, and it uses some different characters and different length. Yeah, but they all belong to the same campaign. Also, sometimes, like in here, in the query part, they used emails, which then make the front part kind of change. And of course, here you could maybe just use an email pattern to kind of plug it in, then we would be the same. But this problem persists over spam campaigns. And it's beneficial to kind of have only one pattern per spam campaign, or at least only a few, because it reduces kind of the compute power that you need to match all the URLs against when they come in. So you can be a lot faster. But of course, as we're going to see, there's also the chance of erasing false positives. So whenever you generalize something, it's less specific, and you might catch things you actually don't want to catch. A simple approach, we tried to group kind of the same regex patterns together, was by just erasing the length description. And this works quite well for very descriptive or long URLs. But yeah, whenever the URL gets shorter and maybe very generic, then you start to have benign URLs in your groups. And this is, yeah, not bad, because mainly customers complain about emails not going through and not like the other ones. So we tried to filter out the false positives again by extracting n-grams from all the URLs in the group. N-grams are just a sequence of characters that are the same or shared by all the URLs. And this is, for example, an n-gram of 13 characters. And yeah, so what's actually good about the, extracting the regexes before is that it makes the data amount kind of manageable. Because if you would just kind of do string comparison of millions and millions of URLs, somehow the compute would not, or it would take forever. So by kind of pre-grouping these URLs that are likely very similar, we can then apply more advanced clustering and pattern matching techniques like string matching. So let's see how this goes. Of course, you will have in emails a lot of marketing examples. And they also all have automated patterns in URLs that you then do detect with this. So what you actually need to do is kind of think about to what email traffic you're actually going to apply this to. And for us, of course, kind of having listed or filtering out all the marketing-related domains, also like common marketing URL patterns that then are not used as n-grams. But if you then focus on new domains and maybe also new emergent patterns, then you're quite successful in kind of extending the pattern matching by grouping and then extracting n-grams, and then you only can kind of search by this n-gram string in incoming new URLs. Okay, so I think false positives is quite big of an issue, of course, with this, because we have somehow not really... So with incoming emails, we detect them and they go out. And the only feedback that we actually have for whether this detection was right or not is whenever all the customers are happy or whenever there's a misclassification and then they report it back to us. But of course, that doesn't cover like the whole databases. So we have to be very cautious about whether we introduce false positives or not. And for us, that we could see work well for at least our data base was that if you have URLs that resolve to regexes with more than 50 tokens, the false positive rates are acceptably low. With regex tokens, what I mean here is if you divide, like what we saw in the beginning, how you kind of divide each regex, if you each token is one sign, so either a special character with meaning from an URL, or a part describing the character type used in the string, or the length part if you have a length description in the regex. As soon as you go lower, the false positive rate starts, and you need longer n-grams that you can extract that are kind of uniquely identifying all the URLs belonging to a spam campaign. I know this is quite restrictive because, of course, not all the URLs are as long, but for what we observe, a lot of spam campaigns actually have very long and descriptive URLs. So, to see what we did so far. So we had the basic domain detection, we added the parts extracting the regexes, which worked very well, and then grouping the regexes and filtering by n-grams. Works well for some cases, but of course not for all of them. Yes. So I'm actually about to finish, but a quick note on whether we can maybe detect these regex patterns by machine learning, which is a new thing that we were looking into. There, of course, we also have the same problem, like we need really clean labels, and having these groups and not knowing really whether there are false positives in there, that might kind of skew the model. But for the examples that I showed and like the kind of indicators that we put in, so putting in only clean cases, this also works quite well. And yeah, so looking at the key takeaways, these regex patterns helped us to link related domains fast and thereby kind of paint a complete picture of the spam campaign. And for us, it also helped to kind of divide and conquer the large database of the URLs. And it also actually helped us, for example, for marketing campaigns. You sometimes see very interesting information on how they are related, but you also could kind of do more expensive, computationally extensive analysis on these kind of groups or pre-grouped data, which was not possible before. Yes, so I was very quick. Thank you, and time for questions.